Okay, cool. So again, I'm Sean Kenny, and I'm going to be talking about testing Android at Spotify and just some of the higher level principles and methodologies that we're using to test our app, and then also diving into a couple key places just to show some of the underlying features and sort of implementations that we have for testing. So pretty much we move really fast here. So it's definitely agile. I'm not really sure exactly what kind of agile it is, but it's agile. And we start a release cycle by designing and then building and then testing and then releasing. It's just one big cycle that repeats. And the end of the cycle, we get a released version of the app that actually goes to the App Store and all of you can enjoy. Either way you look at this, like any way you look at this, it's just a tight cycle. And we move fast, and we release every 3 weeks. And if there's a bug, we're going to ship your bug. And once your bug is shipped, it's going to be a little while till that bug goes away because people install it, and then eventually they'll need to get a new version and things like that. So fast development cycle puts a little bit more pressure on needing a good testing system. We also have a lot of developers at Spotify. So over the years, Brian was saying he was the first New York City Android engineer. I don't know exactly where that is here, but right now it's a lot of people. So we have over 40 contributors committing code to the code base, and that's like regular committers. We also have people that just maybe fix a bug, or they didn't have anything to do that weekend and fixed the bug for us, which is great. So pretty much, there's a lot of people. You don't know what everybody's committing anymore. You could break someone's stuff, they could break your stuff, so testing is becoming really, really important, especially with a lot of people using the app. However, I can prove to you that even though we have more people, we're releasing quickly, and we're growing, and the app is getting more complex, the crashiness of the app is actually going down. So if you look at 1.1.0 compared to 1.6.0, that is actually crashing about 20% less than the actual. Well, it's 5 times less than 1.1.0. So that's pretty awesome. When we put this together, it was really eye-opening to see that, and just by adhering to some testing principles, making sure you're doing what's right in terms of testing, you can definitely do this and get better over time instead of going in the opposite direction. So how do we do that? We protected our code with tests. Really mean, nasty tests that are great and defend babies. So we write unit tests, automation tests, we do exploratory testing, we have all kinds of different testing. And the way this kind of shakes out, this is kind of how I look at it. I mean, you could probably break this up different ways. We have unit tests at the bottom of our pyramid that are pretty much, they're all Robolectric tests. And you don't necessarily need to use Robolectric for this, but we really like it, and I'll go through a couple reasons why. We also are doing automated tests, and that kind of includes UI tests, like actually clicking around and doing specific use cases, smoke testing, stress testing too, integration testing, end-to-end tests. And then at the top, we're still doing what we like to call exploratory testing, where we have many people using the app and just sort of exploring, figuring out what's wrong with it. So first step to achieving less crashiness, you take a strong stance on making unit tests. So unit tests are literally our first line of defense against bugs. So we pretty much took the stance of, you write unit tests. If you're not writing unit tests, then you pretty much just wrote legacy code at this point. because it needs to be tested. Why would you write unit tests? You ensure that all your code paths are, working as you thought they would. You root out complex things in your application. I've refactored many classes because it wasn't testable. And at the end, I don't think I've ever done that and thought like I had like a worse thing there. It's just more modular. You could use dependency injection or something like that. It was really nice. And testing kind of forces you down that path. What do we test? Typical paths, the happy path, if you will. We test like weird data conditions, empty sets, maybe like, off by one errors or like lengths on substrings, the extremas or something like that. There's a lot of things to test, but unit tests can normally cover a lot of different things. So what we use is Robolectric, and it's basically a really, really fast way of doing unit tests for Android. So it uses the JVM, if you don't know what Robolectric is, to run your tests. You don't have to like start Android or anything like that. And it provides you with basically shadows of the classes and objects that you're used to using in an Android environment, and does things like inflating layouts, loading resources, pretty much anything that you need to do, but you don't have to start Android anymore to do that. It's really good. We don't even use a custom test runner. We just use out of the box. It's good. And we actually, I believe, have committed code to make it even better. We use Mockito a lot. Like, what would unit testing be without a good mocking framework? It's really, really fluent. It lets us test things like network connections, maybe other services or libraries that we're not interested in testing. So it really helps you focus on testing the thing that you built, and then you can start to just mock everything else at that point. Another tool that I actually learned about here that I really like is AssertJ. And this really makes testing Android components really easy, especially views. You can see if they're gone or they're invisible. It's very fluent, so you don't have to like string a bunch of assert conditions on multiple lines. You can just sort of string together a bunch of commands that you think the view state should be in. And I actually don't think, we're actually using Fest, and it's been rebooted as AssertJ Android, I believe, at this point. I'm not sure how recent that was. So just going to pull up some code here and show you an example of how we test our fragments. And fragments are kind of like, I look at them as one of the harder things to test, and just sort of review some of the pieces of doing that. So this is actually one of our fragment tests, and this is testing a list of basically listeners for a piece of music that others have sort of navigated to. So one thing that makes testing fragments easier for us is we actually have a very nice base class that we call our Robolectric fragment test case. And pretty much what you do is you just pass this the fragment class. It's generic, so you can pass in other fragment classes as well. And then you just have to implement a single method that pretty much does all the work setting up that specific fragment here for you in terms of setting up an activity that uses a special activity that we use just for testing, starting it with the proper life cycle. A thing for us, so we can't use like standard Robolectric start activity, is like setting up a new theme for us. So this class is basically an extension of the base class that just implements a single method, and at the end of it, if you do this properly in all your tests, you can just easily have a base condition or a base method here called Start Fragment, and then it gives you the fragment, and it's set up an activity, and you really don't have to worry about anything. What we were finding before, especially with activity testing, is that like each class was doing a lot of the same things, starting a shared activity, setting the theme, doing setting a custom preference saver and things like that. So we sort of consolidated all this logic for testing fragments into a base class. So that's kind of like one quick win you can do if you're using Robolectric. And then Robolectric, as you can see, like again, think about this in the JVM just executing. So now you have a fragment. Now you can get the view. You can get the list view. You can do some quick assertions on that view using assert J or fest, so you can see that it's not or that it's gone. So for this specific fragment test, it's actually pretty simple, which is why I chose it. So we test a couple key states. We test that it's empty if no data was around. We test the network error state. So if there was a network problem getting the request, we set up some mocks to do that, and then we make sure that the proper view is shown. We also test things, just the happy path. So right now we set up some mock data. When this is a helper method that basically says you're online and you're going to return valid data for this list. And then we're querying the list view to make sure that the mock data has been loaded properly and it has the proper counts. It's just a nice, quick way to verify that your fragment is working the way that you expect it to. And it's really, really fast to run. And it really makes you happier as a developer to be able to quickly put these together and run them and just know that things aren't broken without having to go through a long process. So if we jump over to Robolectric fragment test case as well. So this is the things that I'm talking about that make this a little bit, that sort of takes the onus off you as the developer. So we're using content providers here, so we're registering a custom content provider. We're putting some mocks into the activity to be used. We're injecting a fragment generator. This is all boilerplate stuff that was kind of used, or the same general pattern was being used. We also tear things down properly, clear test injections. And then this is the piece that starts an actual activity that you can work with. So we use the standard build activity. We actually get that activity, and then we do other things with it that our application needs. Your application might not need it, but it's possible that you do. Okay, so I'm just going to jump back. So that's just like a glimpse into Robolectric testing. It's really, really useful and powerful. And this is an example with a fragment. Anytime you need to use a context, like I have tests that are just testing logging classes that need a context so they can make like an HTTP request or something like that, or a loader. So you can use Robolectric for those kinds of tests really, really easily. So I highly recommend it. So we're actually at, today, 38% coverage of our app. I know that's not awesome or anything like that, but it used to be like 5%, and we're going up. So we're getting better, we're improving. We're gonna get to 100% someday. And then all these Robolectric test cases, because they run so fast and they're so easy to run, not only are developers running them, but on every commit that you make to a code review system that we use called Garrett, it's running these tests for you, and it's telling you if you broke anybody else's stuff. So you can actually like multitask at this point. You can make some changes and ship it off to Team City, and then have it run some tests and tell you if anything broke while you're maybe doing something else or went to lunch. So it's nice. We run these tests the most out of any other testing layer. There's lots and lots of tests, and they run often, all the time. And then we're also actually like showing people the testing levels of things they're working on. So we break our app into spotlets. So this is actually a feature in the Spotify app. I don't know if you can read it, but if you use radio is awesome. 90% test coverage. So if that crashes, I would be pretty surprised. But I don't know about these guys here. Okay, so that's unit testing. So we also do a whole different level of this, which is test automation. And so test automation, let's just show you guys test automation real quick. It's pretty exciting, actually. So what this is going to do is just run a pretty simple test that starts the app and verifies a play count for a shared item. So I'm going to run this, and it should kick off. And then I also need an emulator as well. There you go. And I'm using Genymotion. So we're building x86. Come on. Let's look at the console. Oh, here we go. So, okay, so basically this test runner, a couple of things it does. It installs the app, uninstalls the app. Well, okay, so first it uninstalls the app, reinstalls it, and makes sure that you're sort of at a base condition with the latest version of your APK. And then it acquires a new user, and we have a centralized way of doing that with a service. And when you're acquiring a user, you tell it the kind of user that you want, premium, something like that. And then it goes through a test process. And for some reason, mine is snowing, which is interesting. And it's sharing a post right now. And then it's going to go to the activity feed, pull the refresh just to see that that thing that you shared came up. Play it, and then verify that the replay count was incremented. Back in the day, I did not know what to look. Cool, so that's just one example of a TA test, and that's actually like a really simple TA test. They get pretty intricate, and I'll show you an example of that. And this is just sort of the output of that command. So a little glimpse into what's happening is right here. You guys can probably see the 200, but we're starting a server connection, and we're starting to send commands that map to basic test automation drivers that are baked into the debug version of the app. None of this stuff is actually put into a release version, but the debug version is a little bit super and has extra stuff to automate some of this testing. So this is an older example of like what we're actually doing. So we have devices that are plugged into a computer, and we're picking the most popular devices at this point. So for example, sorry, I lost my note. We have like Samsungs or Nexuses and things like that. And then we also have x86 emulators as well running these tests. And we're currently in the process of upgrading this a little bit to use a more advanced system with like a USB hub and things like that. So we're continuing to improve this, but testing on real devices is a good thing. So this is actually an example of a test that's run, and the test you just saw used a system like this. This is a graph model for testing, and it's actually really powerful. You may have used, depending on what you've worked with, like DSL versions of testing, like Gherkin or something like that. So this is another way of doing that. You represent what you're doing in the edges here, so you're performing an action, and then in the vertexes you have different states that you're going to check. And the power behind this, which is really cool, is when you have this test set up, you can walk it with another tool called Graph Walker in a variety of different ways. So you can walk it randomly until you hit every edge. You can walk it a star until you maybe reach 5 minutes or something like that. So using this way of defining tests, you can actually create a system that is a little bit more complicated and performs a different array of being able to test a single thing. So you can walk this in many different ways, and you've just made a pretty complicated use case using just a GUI tool and then a command line tool to convert that to actual code. And this gets converted to Java code, just like your DSLs or something like that. You'd run a command, you'd get an interface that you implement, and then that gets run as part of your test model. So, and this is an example of the code that you spit out when you're building these models. So here is an edge that needs to click user's profile. Here's an edge that needs to go back. And when you're implementing this as a developer, you actually make it do these things. It's really, you know, it's dumb. It's not going to do that for you. And then this is a pretty interesting sequence diagram of what's happening when we're actually running these automated tests. And just to sort of like walk you through this, I know it's big, but if you break it up, it's not too bad, and it might make things a little bit more clear. So on the console, you actually saw you were issuing commands, page.navigate or something like that. That command gets transmitted over a socket to a socket server that we call bean remote. And then it gets dropped into an interpreted environment that you may or may not have heard of called Bean Shell. And it's more or less our scripting environment. You could probably do this in JavaScript or something like that if you're inventive. But we're just using Bean Shell, which is a small, lightweight tool to execute Java as a scripting language, very small. That actually calls something that's implemented the graph calls that you just converted, and you implemented that interface. So you have a page implementation that clicks a button or goes backwards or goes back. And then that page implementation is actually communicating with an automation driver that's baked into the fragment that actually sends those commands or UI inputs or whatever you need to do to fulfill the action that you want it to do. Once the operation is complete, it collects things like in the example I showed, it would click the button and then collect the current play count, returns the result, and if it needs to, there is a step to convert data like cursor data to a more, I guess, an easier to use format, like just a standard object that can then pass over the wire. It returns that result to the bean remote as it's just a socket connection, and then it goes back as either like a simple string, an integer, or long, or some serialized JSON data that gets picked up and examined, and then the test model can assert if that was actually something that was expected or unexpected. So it's actually, once you get your head around it, it's a pretty simple way of doing it. It's really, really flexible. It's similar to Robotium in that we have like a solo object that lets you do things and command things. And we're, I guess, a couple key breakaways here is we are breaking the logic into pages. So one major thing that we're using is the concept of a page that really consolidates all the logic for a specific it's either an activity or a fragment normally. So each page will have a bunch of functionality, and then the bean remote lets you control various pages, or it has like more useful things like controlling navigation and things like that. So that's pretty much it there. So what this makes possible too is not only these, these predefined models that people have to build and verify and that it fulfills testing needs and conditions. You can also just do some really simple and convenient smoke testing as well. So we have a couple systems, smoke/stress testing systems that we've implemented that have actually found a couple nice bugs, at least for me. Like I've already found 2 or 3 bugs because of these particular tools. So the first one we call Intent Roulette, and Intent Roulette is basically a system that takes every available intent, randomizes it, and then goes through all those intents. So, and then if anything crashes, then you know that you've broken something. It sounds like a really simple test, but I think sometimes you need simple tests like that because it really is a sanity smoke test. Like if something is broken in this intent roulette system, then there's definitely something you need to look at because it's not doing anything really complicated besides starting your activity or your fragment. It's just making an intent and using the shell am command to start that intent and verifying that it didn't crash. We also have a really awesome tool called Monkey on Steroids. So if you've ever used the ADB shell monkey command, this is a version of that you can control a little bit better. So we've given the monkey some steroids in that it can now log into our app and then it can navigate to a random location, and then it can start to actually monkey around and do random things. So it's just it's a monkey that takes a little bit of preconditions and things like that to get you to somewhere where you want to monkey around. And this monkey test is actually implemented as a testing model in our system. So we have our start condition, and then we install and we make sure that we're still alive. And then we release the monkey here. We monkey around for a little while. I think it's between like 1,000 or 2,000 commands at random. And then after we're done, we browse again to a random location. And if we're still alive, then we keep doing that. And we do this, I think it's configurable, but I believe the default is like 30 minutes and then run again or something like that. So it's a really nice way to just sort of get out of your standard testing methodology or models that you've made and just see what happens in pure chaos and try to uncover things. And you can also find things like memory leaks because this thing is just going on, and you might have some memory issues that you didn't recognize that you had or something like that. So it's a pretty simple but powerful testing model, and I can actually just sort of demo this real quick and just show you guys like what that process looks like. So unleashing the monkey. Okay, so here's where we help the monkey a little bit. It's going to acquire a new user and log them in. And then this is the point where we literally, when it says monkeying, we just use the shell command, the shell monkey script, and ooh, it seems like it's gotten into the debug settings. That could be dangerous. Oh, God. Oh, man, it crashed the app. Oh. Monkeys. All right. So, monkey made me look bad. We'll look at that later, I promise. Okay, so we're running all these tests all the time. They don't run on every commit, but they run like every hour or hour and a half. So once a test set finishes, it just picks up the latest release version and then does its job again. And we can actually see what's happening all the time on our TA automation tests. So there's this on a monitor where in a room with our squad that's just sort of showing us what's happening with the specific features that we're working on. So I might walk in after a cup of coffee and be like, oh, shoot, this doesn't seem like it's working anymore. Looks like I have something to do. And then you're pretty much either, very, very happy with what's going on here, or you have something to look into. And we do have like a very, very nice tooling around this as well. So all our test suite, our automated test suite has a centralized shared library that can basically add new tests. Every test suite has access to what's called a report object, and it can do things like upload screenshots. So if there's an issue, you can actually click on this, go through it, and see the screens for every step along the way, and you might see what happened. But normally what's more important is also like a crash log or something like that. The test suite also has really, really awesome graphs that we're powering with Kibana. So over here we have a graph of the test failures per device. Here we have just test passed or failed over the last 12 hours. Here we have test exceptions based on type of exception. Here we have test failing per group. So each group or each suite can be broken up to different groups with an annotation that we have. So it just uses that data to break it up into groups. Here's actual crashes on the latest version. So we're just sort of making this data readily available and up to date. So it makes the TA system even more powerful because you can constantly inspect the data that's coming through. So the last thing that we do is exploratory testing. This is Dora the Explorer. My daughter loves Dora. And so exploratory testing, the best way to do this, at least I think, is just to be organized, at least up front. So have like a meeting and just sort of discuss like what this app is doing. Like what are the different use cases? What are the different conditions and user conditions and things like that? Try to see how complicated the app is and like how many things need to be tested, because a lot of these are permutations of the previous thing. You could choose like one cell in each one of these columns and then like make a test for that or something. And then once you're organized and ready, have like a lunch or get a bunch of people together, give them devices. Not everybody has an Android phone. Maybe an iPhone user could find a bug that you didn't think about. Just get people together and play with the app, test it, try to break it, and have a little fun. But exploratory testing is expensive and it wastes people's time in some ways. So try to move your exploratory tests to automated tests as much as possible, so that you don't have to keep doing each one of those processes in that Excel sheet that I showed you. You could automate that and basically make things a lot faster. And then we're also doing nightly builds, and this is kind of new. We're using a Play Store feature to allow people within a domain, Spotify.com, to get the latest bleeding edge copy of our Android app and download it and install it. So this is every night you get a new version of the app installed. I normally get it on the train in the morning. And this gets 175 people using your app daily. And it's great. Like before, it was a real problem when you're working on a feature and maybe the only people in your squad have used it. Now you can release it to the company and see if anybody finds anything. Maybe they have feedback. Maybe they have an opinion about what you're doing. It just helps keep surprises down and I think customers happy in the end. We're also doing crash reporting. So we use a system called Hockey App to basically get all our crashes, and their API is really simple to use and integrate with your application. I don't know why this graph looks like that. That's interesting. We had a really good day on the 27th, apparently. But the takeaway here is you can see your crash counts. So if you're rolling out, you might notice that like you've just introduced like a major crash group or something like that. You as a developer can go and search and see maybe you can find some crashes that are happening in the wild and get the stack trace and sort of figure out the major issues. I try to go here every couple days or something and just see, the features that I'm working on. You can give it a class path. Are there any major issues? So I think the other day I fixed that one down there that had 165 crashes on 1.8.0. And so this is really great, and it actually does make a difference. So just circling back, this is a good trend here. If we continue this trend, it's a good thing. Crashing is not great for users, and we're doing less of it with each version at this point. And I think it's because of the tests that we're doing, and the automation tests and the unit tests. And at this point, I feel like we're starting to win a lot. We feel really good about what we're doing and the processes that we have in place to make sure we're not going in the opposite direction in terms of crashes and testing. And I think our users are happier. We actually downloaded Google Play data and did some sentiment analysis. People are cursing a lot less when they're commenting about our app, which is a good thing. So just to recap, strive for higher coverages, make it easy to get started in testing. Remember the Robolectric based test classes. In the automation tests, we have so many helper libraries for waiting and doing things and reporting. Make it easy for developers to test. Run the tests as much as possible. Unit tests, Robolectric tests, you can run so often. Every developer can do it. It doesn't take much time at all to run the entire suite. TA tests take a little bit longer, but you can normally parallelize that, get more machines to do it. Make your results available with reporting, the TRS reporting that I showed you with all the different colors and features. You'll know when something's broken. And then analyze what's happening, and then if it's not going the way you want it, reanalyze and see what you need to change to make stabler and better. And that's it. Questions? In production? Yeah, it's hockey.
How did you manage to find the problem that drove that 165?
In hockey app? Yeah. I looked at the stack trace.
Yeah, because in the stack trace, maybe in the new phone, you don't see the error. So how did you correct it?
Oh, you mean if it was a device independent thing? That would be a little bit harder to find. That particular issue is pretty clear, but we do have a lot of testing devices available. So if I suspect that that's the issue, I'll probably go borrow 5 phones from a TA tester or something like that on his desk, and tell him I'll bring him back tomorrow or something. Sure.
So, do you use hockey is that because that's what was there, and if it's not broke, don't fix it, or do you evaluate the other tools? Because it seems like the world has moved on a bit in sophistication, maybe not.
Yeah. Unfortunately, I'm not the best person to answer that. Perhaps Eric might know a little bit more. He's been here longer.
We look at we look at other options as well all the time. We keep evaluating every tool we have on a regular basis, including Hockey app, of course.
Yeah. I mean, I know there's Crashlytics or something like that.
Crashlytics sucks because obviously you're giving your data to somebody, and maybe that's not what you guys at your size would like to do. But I found that crash reporting often without a log doesn't give you a lot of context as what was happening before the crash, which can make life easier if things are complex. So I don't know.
That's a good point. Yeah.
Anyway, that's that.
Anything else over there?
I have a question about your test automation framework.
Sure.
What is the tool set behind that? How much of it is stuff you create yourself?
So that test automation system is unique. It's very custom for us, and it's probably a combination of just like integrating with pre-existing things that we have here, like the test reporting system is something that's here for not only the Android app but the iPhone app, things like that. But it's actually like pretty like simple. Like it's not overly complicated to do. If you want to talk about like how we actually do that, the high level is that we're creating socket connections, and then we're using, probably the key thing is a thing called bean shell to just execute commands that you're sending over the wire, and then we're just doing some basic parsing and deserialization of the results, and we're sending back like 200s and 501s and things like that for error conditions. But I mean, you could probably do it a different way. But I think the key takeaway is just try to do automation to get like a lot of the things done that you might be doing yourself or other people are doing. Try to get testing automated as much as possible, and try to make the data accessible that you're getting from that automated testing. Yeah.
Were you also able to like see correlation in the number of issues filed in your bug tracker, or developer hours spent in bug?
I did not take it that far actually, but that would be interesting to see. All I did was do some analysis on basically Hockey app to get crashes for each version, and just sort of the way that was calculated is we actually send a baseline crash, like maybe every 1,000 crashes, that doesn't crash the app. It's just a non-crashing exception that gets sent to Hockey app, and then we know the general usage, and then we use that baseline to pretty much calculate the actual failing exception percentage. But I haven't tried to take that and correlate that to anything else. But that'd be interesting to do for sure. So you're talking about the automation drivers, the things that are actually clicking around and like doing the UI interactions? Cool. So the question is like, how do we not, like, I guess it's how do we not dirty our app with that kind of thing? So I think the way it's been approached is, every Fragment does implement an interface that provides an automation driver, and then that class can really live anywhere, but normally it's baked as a subclass in that Fragment. However, these things, these like different fragments, they normally don't do too much, so it doesn't add too much extra code. And then the actual pieces that communicate with that, so there's another layer here. So you have that, and then you actually have the page object that is talked to remotely with the bean remote and the bean shell. That is considered, I want to say, an adapter to those actual UI automations that the Fragment is doing. So that can be as complicated as you need it to be, and you actually wouldn't be touching like actual like UI code or actual application code that a regular user would use on a daily basis. So it's layered a little bit. So there is a class in between that talks to that automation system, and then it can sort of, that could compose a bunch of different commands to do different things that maybe the automation driver doesn't do.
Yeah, so for your intent roulette system, which was firing random intents,
Yeah.
is that only something you use for like forward-facing activity or an exploited activity, or do you use that to
I believe that it's using just the main activity. So it's sending a request to start the main activity, and then it's sending along a little bit extra. We use like URIs to decide which place to go after that, and the main activity will typically take that and start a subfragment or a fragment from there. Yep. Oh, you. That's a great question. How much time do I actually spend testing versus developing? I think as the tooling gets better, I'm doing less testing. So I think at the beginning, when I was still sort of getting used to our setup and things like that, it was maybe like 60-40 or something like that. But now it's getting closer, I want to say, to maybe like, I don't know, 80-20, maybe a little bit less. So I don't know like how you do testing, but I haven't really gotten like test driven first. So I'll normally develop a component and then make it tested. But I think the general takeaway here is I'm trending downwards in the time that I need to write an actual test for something. And I think that's because there's a lot of people identifying the pain points. So if like something is hard to test or there's a core component that a lot of people are using, somebody generally comes around and provides either a class or a helper or something like that to make that process easier. And we do have like a Java guild where we can talk about these things and make the testing process less painful. Because if it's painful, nobody's going to do it. Okay, cool. Thank you, everybody.
Thank you.